Hi. So I explained there are four different possible outcomes, in this scenario, in this situation. And we are going to put some specific numbers to this example. Suppose that, suppose that in our example, the detection rate is 99%. Very accurate. This is what my doctor told us. I don't exactly remember the number, but it was pretty high, like this, 99%. And specificity is 90%. So, or specificity rate or selectivity rate, and false negative rate is 90%. And additionally, assume that birth defect happens for 1% of babies. 1% of babies are born with some birth defects. That is our numerical examples, but I'm telling you this probability is much smaller than 1%. So birth defects is much less than 1%. I'm just using 1% as an example, just to simplify the numbers. If it was 0.001, then the probability will be very much complicated at the end. So I'm going to, it's not that realistic, but I just want to give you the example. Still, it sounds like, so imagine what I want you to imagine is that, suppose that you or your wife is pregnant, and the doctor told you the baby is at a high risk of birth defects, and this screening test is very, very accurate. The detection rate is 99% according to many researches. Okay, then you have to prepare for the birth defects, or uh, do you need to be panicked? My answer is no. To do that, you have to understand how to calculate the probability you want to know. And I already taught that how to do that, the tree diagram method. And now use the tree diagram method with 10,000 hypothetical sample size. Use hypothetical 10,000 sample size and fill this frequency distribution table. So that means, suppose that there are 10,000 baby samples, baby blood samples, or whatever, babies, and you are going to classify them into these four categories using these numbers, these probabilities. We have done the same thing in the previous example. So you should be able to do the same thing after, by like if and similar in a similar way to that. And if you need help, you may go back and see what we have done. Like go backward in the slides and check out what we have done at the time. And do this by yourself and find the appropriate number for this entry, for this cell. Try this and see what is the correct number. Pause the video and do it by yourself. It may take a little bit of time. Of course, you may use a calculator or Excel or whatever you want. Try this, and I am going to do it. I'll show you how to do it. So if you have not tried it, please do it first by yourself. Okay, so we assumed 10,000 babies. We tested 10,000 babies. And first, at the first step, we have to use unconditional probability because there is no condition, just there are 10,000 random babies. We have no information yet. Among 10,000 babies, 1% have birth defects. So 1% of 10,000 is 100 babies. So there are 100 babies with birth defects. But the other 9,900 babies do not have any birth defects, right? That's the first step. And at the left, out of 100 babies, so if you test, if you do the test, conduct the test on these baby samples, then 99% of the results must be positive, and only one, it means only one negative result. So out of 100 babies with birth defects, 99% get positive results, but one baby has negative results, right? And we are using, remember, we are using this conditional probability given birth defects, because we know that already 100 babies do have birth defects. So that is the information we have, and that's the event that already happened. So we have to use that information in assigning the probabilities. And from the right, out of 9,900 babies who do not have birth defects, 90% would get a negative result. So 90% of 9,900 equals 8,910 babies. So calculate it to the use a calculator, and so we've found 8,910 babies have no birth defects and they get negative results, which is correct result. But 990 babies still get positive results, even if they do not have any birth defects, right? So again, use this conditional probability. We are using 90% given not having any birth defects. So from this node, we have that information. Then we are done. We have done everything. So we have 9 categories. So our question Z was those who have birth defects but have no negative result. The answer is 1. There is only one baby out of 10,000 who have the birth defects but get a negative result. Okay, yeah, I filled out the table here. The frequency table out of 10,000 becomes this. Now determine the probability. Determine the probability of having a birth defect given that your baby got a positive result. Try this again by yourself and compare your answer with my answer. Pause the video and I will show you. The condition is P, so you only look at these numbers. That's it. So only these two numbers satisfy the condition, positive result. So this many babies who received positive results, how many do have birth defects? There are only 99. 99, there are 10 times more babies who actually don't have birth defects, even if they got a positive result. So the answer is B. The answer is B. So it's the same conditional probability, calculating conditional probability from the frequency distribution table. So out of this many positive results, only 99 actually have birth defects. So what I'm going to tell you here is, even if the positive result and the high good accuracy of the screening test sound scary to you, but practically still the probability is positive, but it is not that high as many of you just feel. So when you do the math, the risk does not need to be that much exaggerated. Still, like, by the way, this 9.1% is already much larger than the reality, because as I said, the actual probability of the birth defect is much less than 1%. But just for convenience, I used 1% as a numerical example. So the final result is 9%. Actually, it should be much lower than that. So when in the future, when you got a positive result for your baby or for yourself, whatever, don't be panicked and think about what I taught you and look at this slide and do the math by yourself. My wife is a statistician and we did it on that day, or like after coming back from the hospital or the office. So it's an interesting example that tells you why you need to understand the Bayes rule and the conditional probabilities. It is exactly the Bayes rule. You may use the Bayes rule formula. The Bayes rule formula goes like this. You may plug in, we already learned, it's a detection rate, and 99%, 1%, and this is, it's a typo, excuse me. When I upload this slide, I will fix this typo. It should be 1% because when there is no birth defect, the positive result should happen only with 10%, right? So you may plug in the numbers and you will get the same number. Plug in the probabilities, get the same number according to Bayes' rule, but it should be the same as this. I have shown you how the formula was derived from the tree diagram idea. Right? Okay, this is it. Thank you for watching this. And in the next lecture on this Thursday, we will start chapter 3. Chapter 3 is about average. That's just also very straightforward. So see you in that video. Thank you for watching this.